Hi, my name is Raphael, and in this video I will talk about assignment 3, match 3, the shiny update of the CS50's Introduction to Game Development course. So in this video I will explain my implementation for this assignment. So first let's look at the goals. So first goal is implement time addition on matches, which is pretty simple. We can look into the code right now. So in the playstate calculate matches function, we have the for loop where we then add the score, and we just need to add a line which increments the timer. So for each tile in a match table, we increment the timer. So if you match 3 tiles, the timer gets incremented for 3 seconds. Okay, let's look at the next goal. Ensure that level 1 starts with just simple flat blocks. Okay, so we need to do some more for this goal. And of course, in later levels we want to generate blocks with patterns on them. So, and yeah, we should also look at the colors. But this is also a bit part of this goal, as we see here. Choose a subset of tile colors. Okay, then I will just talk about the variety stuff. Yes, so we need to first, so we need basically to pass the board function or the board constructor to, we need to pass it level, so the current level where we are, so we can do stuff that's based on the current level. And this is done in the begin game state enter function. So let's go to board file in the board init function. Sorry, it's way up. Okay, here we are. So this is what I added. So I will cover the color too in this goal for now. So basically before we just choose a random color from this sheet, but there are too many colors. So I decided to choose a maximum of 10 and yeah, a minimum of 6, so level 1 plus 5 is 6. So yes, in the first level 6 colors and so on, and it goes just to 10, and then if you're at higher levels it's yeah, always 10 colors. And for this I also wrote a function called getRandomColors, which is a line at line 3 or 5, I believe. No, it's not. Sorry, 3. Yeah, here we are. Board.getRandomColors. We pass it the colors count. So, for example, for level 1, this would be 6. And then we just fill a color table 6 times with a random color from 1 to 18, because we have 18 colors in total. And this while loop just ensures that we don't have duplicate colors in our color table. And then we return the color table. And this is stored in the variable self.diffColors. And then the interesting stuff here, variety. So we also want like flat tiles, so tiles with no symbols on them in level 1 at least. I decided to do it in level 1 and level 2. And then every second level you pass, the variety is increased to a maximum of 6, because we only have 6. And yeah, this ensures that it's like every second level this is like incremented. Okay, so for level 1 we have max variety of 1. For level 2 also. For level 3 we have max variety of 2. And then these two variables come in play in here, for example, in the init initialize tiles function. So we have here a local variety which basically just is assigned if probability of 1 to 6, or how do you say it, 1 divided by 6, which is around, I don't know, between 15 and 20% chance. So if this is 1, so this certain amount of chance, then we just generate a random variety between 2 and 6, because 1 is the base variety, which is assigned either way. And then, of course, math.min self.max variety. So if we choose randomly a high variety, then the max variety is chosen here. And then this is assigned to the variety variable. And this is passed to the tiles init function here at the end, variety. And also passed is the color, so we just select the color at the random index, basically. The colors table. Good, and these two lines also appear in line 305, where we create tiles if we like get a match and then we get falling tiles, and this is just the same as above. Okay, so one more thing to show for this goal, line 215. Oh yeah, of course we want to add a bit more score if you match tiles with a certain symbol on it, and this is just done by this little addition here. So tile variety -1, so variety 1 equals 0 then, so we get no additional points, and then for each symbol we get a multiplier of 20. Yes, okay, let's look at the next goal. Here is everything all right? Good. Okay, the next goal is create random shiny versions of blocks. Why is my mouse not marking? Okay. That will destroy an entire row on match. Okay. Granting points for each block in the row. So I just figured out that I have also implemented to destroy a column if the match is in the column. So if the match is like 3 tiles which are column-wise matched. Okay, interesting, good. Should not be an issue. Okay, first things first, we need shiny blocks. For this I just added a graphic particle PNG, which is the same particle as we used in the breakout game, so breakout lecture, so please refer to this. And then we of course need to use this. So I wanted to create the shiny blocks with the particle effect, so they like shine. And yeah, I can show it later then in the game in the end. So we need, I just added a shiny variable, which is a chance of 5%, so each tile has a chance of 5% to be shiny. And then I added a particle system with the particle and 32 particles. Particle lifetime set to between 1 and 5 seconds, area spread 6 normal, and the colors are so golden particles which change from alpha 100 to alpha 0. Sorry. And then I added a timer, so for every 0.1 seconds we emit 32 particles. And of course, therefore, we need also an update function, which was not here before, where we update the particle system with delta time. And we also need to draw the particle. So if self.shiny is true, we draw the particle system in the middle of the tile, in the center of the tile. Okay, then we need to go to board. So for the shiny stuff, it's almost done. We of course therefore also need a board.update function where we call the update function for each tile. So just iterate through the board. And this function is also needs to be called in the begin game state and the play state. I will not show it because it's pretty simple. Good. And last but not least, line 90. Yeah, of course, now we need to ensure that if we got a match with a shiny tile, that we delete a row, as it said in the assignment, but I also implemented the column deletion if we got a match in a column line. Yeah, I don't really know why I did this, but it seemed logical to me. Okay, so we are here in the calculate matches function, and if we have a match, or like match number is greater than 3 or equal, then there's some logic which was here before. I added the local variable delete row is false initially. Then we check all matches for shiny tiles. So if there's at least one, doesn't matter if there are more, set delete row to true. And then if delete row, we add self.delete row y to the match. So y is fixed, the y coordinate and for the row. So I will go to this function later. And if not, just the basic table.insert match into match the tiles which are in the match. This way it was before my implementation. Good, and this whole logic is called basically 4 times. So here we have, if we have a match during the row, I guess, then yeah, I count for the last row ending match. So if we are at the end of the row, then basically the same logic here again. And then these two things also for vertical matches, so columns. And then I added a delete column variable. So this was not needed as I just read in the goal, but never mind then. Basically the same stuff. And also here account for the last column, also the same logic. So let's look at the two functions, delete col and delete row. They're pretty straightforward. Delete row just gets a y. This is a fixed. And then we just iterate for each x coordinate and add every tile in the table, in the match table, and return it. So we have a match of the whole row, and same logic here for the column with the fixed x this time. Good, I guess this was everything for the shiny stuff. So the last goal is only allow swapping when it results in a match. So this is also a bit trickier, and here, as I said before, we need less colors for this because we would get a lot of boards where we have no matches at all because there are so many colors, I guess 18 as I remember. And so I choose, here is 8, seems like a good number. Yeah, I choose a maximum of 10 as I showed before. So yes, let's look into the code at board line 77. Okay, so first I added the swap tiles logic, which was already implemented before I just put it into the board. It was just in the play state. So we have now a board function swap tiles, tile 1, tile 2, which just swaps 2 tiles. there's no animation or anything, it just swaps to tiles in the grid. Yes, of course. Okay, then I also implemented a board function called any matches. So this checks whether there are any possible matches across the board. So this is a function we need to call every time the board changes, basically, because every time the board changes, it's a possibility that there are no matches, and then we have to reload the board. Since there are only matches allowed, which are swapping allowed if they result in a match. And this is also pretty straightforward. We just swap every tile with every tile and look if there are matches. So we just swap tiles, call the calculate matches function. This returns something if it's true. And so if it's true, we swap it back, of course, and return true. So true. So any matches is true, and else we just swap it back and return nothing. Good, and this is done. So here with the left tile, so self.tiles is the first tile to swap, and self.tiles y is fixed x minus 1. And of course only if x is greater than 1. And here top tile if y is greater than 1, so we don't swap it with a tile that's not existing. Yeah, and this is also done for the right tile and for the bottom tile. Yeah, and if nothing applies to be true, return false. Good. Begin game state line 35. Oh yeah, of course, where we instantiate the board for the first time in the begin game state.env function, we need to ensure that we get a board with matches. So while not self.board any matches, so as long as this is false, generate a new board. So hopefully this is not called too often. It is not, because I have no performance issues, but yeah, we need to ensure this, of course. Good. And now we go to the play state for the final changes. Line 147. Yes, so here in the, what is this function, playstate.update? If we press enter, then a lot of stuff applies, so highlighted tile and so on and so forth. And in the else statement here, we swap the tiles. So there was the swap tiles logic, which I just put into the board now earlier, and therefore we don't need it here. But the playstate also has its own swap tiles function. So this is called here with self.highlighted tile and the current tile we are just in. What is this tile? X and Y is set somewhere. I can't find it. Oh yeah, sorry, here. Highlight. Oh yeah, where our cursor is, basically. And true, this is a parameter for, here it is explained, this is the swap back on no match parameter. So if we pass through here, through true here, then the tiles are swapped back if there is no match. And if we pass false here, this is important for the second call, then yeah, then they are not swapped back. So, for example, if we have a yeah, I will I will explain it. Sorry. Good. So the swap tiles function, we also pass two tiles and this parameter, and if swap tiles is true, so swap back on no match is true, then we need to tween the coordinates, of course, because we want to swap anyway. And then on the finish, so dot finish, we add a function which calls the board dot calculate matches. So we see if there are matches. If yes, then self.calculate matches and we pass them, so we don't have to create them again. And if this is null, we just create matches again. And if not, if there are no matches, just swap it back. And here we now call, we put the parameter, we set the parameter as false. So therefore they will not be checked if there's a match, because if we swap it back, it's like the state is like before and there were no matches. Then we set the highlighted tile to nil. So this is the white marked tile, and we play an error sound. And yes, and when we, as we call this with parameter set to false, we fall into the else statement here and we just tween the coordinates. Yes. So then, as I explained before, we just changed a bit the calculate matches function. We have now a parameter here because we don't want to call this function twice if we don't need it. And then 199, what was this? Oh, this was this function. So yeah, here we are. Okay, so as we finish with the calculate matches logic, now we need to check if there are any matches. So if we need to, whether we would need to reload the board. So we just call self.board any matches. So if not any matches, so if we have no matches, then we set a flag. It's important for later. We play an error sound, and then we make just a logic to display a text that there are no matches. So between it's basically the same as the text for the levels. So it comes from above, then text stays in the center for a certain amount of time, and then floats down to the bottom of the screen, just with a bit more time, because the text is longer and you it takes you more time to read. So this is all pretty straightforward tween stuff. And yeah, once this is done, the tweening, we just reload the board, of course also with the while loop, because maybe we reload it and then it has initially no matches, and then we need to reload it again, of course. And then set the flag to false and the label to -64, so that the level can come from above next time. And of course we need also to draw this stuff. So if self.no matches, here's where the flag comes into play. We set a color, I think this is blue. Yeah, this is the blue rectangle, and then we just write with the medium font, no more matches, reloading board. Good. This was pretty much everything, so I will just show you how the game looks right now. Good, so we start at level 1, and we also have tiles with no symbols, so this is pretty good. We can do some matches here. Here we have a shiny block, but we can't use it, but this one we can, so this one should delete a row. Oh, it's not working. Yeah, sorry, we need to swap this one. So this works, and we just reached level 2, and still flat blocks. So as we expected, so delete the row again. Maybe we can get a column match for the stuff I implemented with the shiny tile. Let's see, I think we need to play a bit. So, oh yeah, here we can make a column deletion. So yeah, looks pretty good too, I guess. Was not required, but why not? Good. And another column match, and we reach level 3. And now we have different varieties. So the variety 2, and then it goes on and on. Good. I think this shows pretty much almost everything. But to show the board reload, if we have no matches, I will set our initial level to level 8 in the start state, so we have more different blocks and it's more likely that we have no matches. And I will probably fast forward this until we get there. Yeah, here it is. No more matches, reloading board, and the board got reloaded. Okay, so thanks for watching. I hope you did understand what I have done, and see you in the next video. Bye.